All right, so our math objective for today will be, I will be able to plot fractions on a number line to create equivalent fractions. So remember when we're talking about equivalent, we're talking about equal, okay? Equivalent and equal essentially mean the same thing. So the next three slides are actually going to be a little bit of review for our liters and measurement. So how many 500 milliliter beakers, which is this one right here, 500, would it take to fill the 1 liter beaker? And this is the 1 liter beaker. So, and remember that 1 liter, which it says underneath my video, 1 liter is 1,000 milliliters. So how many 500 milliliter beakers would it take to fill the 1 liter beaker? How much would it take for the 250 milliliter beakers right here to fill the 1 liter beaker? And so the answer for this one is up here, and the answer for this one is down here. Similar question. How many 100 milliliter beakers right here would it take to fill the 1 liter beaker? 100 milliliter beakers to fill the 500 milliliter beaker. So this answer goes right here. This answer goes right here. How many 1 milliliter drops? So this is a dropper and it only does 1 milliliter at a time. Would it take to fill the 100 milliliter beaker? 100 milliliter beakers to fill the 250 milliliter beaker. Okay. So this answer right here, this answer right here. All right, so now imagine a number line from 0 to 1 with 1/6, 2/6, 3/6, 4/6, and 5/6 labeled. Which fraction is closest to 0? I want you to put the answer right here. Which is closest to 1? And put the answer right here. This is kind of your best guess, and I want you to do this before moving on to the next slide. So we will come back in 5, 4, 3, 2, 1. Think about moving 6 equal distances from 0 to 1. So kind of like you're taking 1 foot at a time, okay? Moving from 0 to 1/6 will leave you closest to 0 and farthest from 1. Which fraction has the same location on the number line as 1/2? So remember, you're visualizing, right? And you're going, okay, so as I move my either finger, my triangle, or if you imagine it like you're taking steps towards something, from 0 to 1, and you're counting in sixths. And so imagine that number line, 0 to 1, and then as you move, 1/6, 2/6, 3/6, 4/6, 5/6, what one do you think is going to be at the halfway mark? And how do you know? I want you to go ahead and tell me how you know. Okay, so let's label the rest of the 6. How could we use the 6 to figure out where 1/3 should go on the number line? So I am going to show you where everything goes, okay? So 0/6 goes right here. 1/6 goes right here. It's kind of close to the 0, but not exact. 2/6 go right here. 4/6 right here, because it's next. 5/6. And then 6/6 is at the 1. Because 6 out of 6 is 1 whole, right? And when you're actually thinking of 3/6, you see how it's lined up with the half, right? What is half of 6? If I were to put 6 objects into 2 groups, how many would each group have? Okay, so I would have 1, 2, 3, 4, 5, 6. So how many is in just one group? 3. Okay, so when you want to figure out what is half, look at the denominator and think, what is half of that denominator? Half of 6 is 3, so this is in line with 1/2. This is an equivalent fraction for 1/2. And even if you put it as a fraction circle, it's going to look like half. So I'm going to show you that real quick as well. And we've talked a little bit about equivalent fractions for half, but it's good that we go over this. So okay, so here's a circle, and it is in 6 different pieces. 1, 2, 3, 4, 5, 6, right? And 3 out of the 6. So when you look at that, when I shade in 3 out of the 6, this is what it looks like. So it's right in line with half. So now we need to figure out, where would 1/3 go? So now that I know where all of the 6ths are, how would I know where 1/3 is? And so you can look at this and look and see, okay, if I were to split this number line up into thirds, I would have 0, 1/3, 2/3, and then 3/3. So it would really be 1 mark and then another 1 mark. So where do you think that that would lie? So how can we use this to figure out where 1/3 would go? Or we can actually take it into our circles as well. So 1/6 probably is not going to be the same thing as 1/3. But I can look and see maybe 2/6 is the same as 1/3. So let me make my circle again into 6ths. Right here, it's in thirds. Okay, so I could shade 1 part and then see how many 6ths are shaded, or I can make it into 6 first and then shade. So I'm going to make it into 6 first, just like that, just like I had before. So I have 6 pieces. And now, so this is 1/6. And maybe it might be a good idea to have another circle that has a 1/3 shaded. So I'm going to do this. So I have another circle that has a 1/3 shaded. Now this 1/6 circle does not look much like this 1/3 circle. So let me shade another piece. And when I do that, does that look more like my shape? It does. And if I go all the way to 3, then I know that I have actually done half. And half is more than 1/3. That would be another line here, and that's shaded. So this 2/6 is equivalent to 1/3. So I kind of told you already how to do it, but that's okay. Oops. Okay, so what we're going to do is we're going to locate and plot fractions on a number line. Plotting fractions means marking the locations of fractions on a number line. So why do you think I plotted half here? Go ahead and answer. Now what you need to do is plot the rest of the fractions. You have a lot of fractions within this bank, and you are going to plot them here on the number line. So for instance, 8/8, 8 out of 8 wholes would definitely be 1. That's equivalent to 1. Oh, 4 out of 4 would definitely be equivalent to 1 as well. So 8/8 and 4/4 both equal 1. Oh my goodness, so is 3/3. 3 out of 3, also equivalent to 1. So continue to do this. They're not all going to be equivalent to 1. And this is going to run down this slide quite long, and that's okay. And do the best you can here. You can also use, on the next slide, here is our fraction number lines that we've been looking at throughout this throughout these past few weeks. So you can actually look if you need help and you go, oh man, I don't know where to plot maybe a third or 2/3. You could look at this. So, but it is important to recognize that this is not from 0 to 1. This is from 0 to 2. So you're only really looking at this, okay, right here, all the way, just this halfway point in between, because we're not really dealing with 2 holes. We are only dealing with 1 hole, okay? So go ahead and complete that previous slide before moving on. And come back in 5, 4, 3, 2, 1. So this is what it's going to end up looking like. And I want you to tell me, how did you do? How was comparing those fractions and being able to mark them all on one number line? Like I said, the ones we're going to run past the slide, and that's perfectly fine. But now anything that is underneath is an equivalent fraction. So now we know 0 halves and 0 wholes are equivalent. 2/8 and 1/4, 1/3, 2/6, 1/2, 4/8, 3/6. All of these are equivalent fractions, and you will be able to use these to work on the next few slides. So moving on from this, now we're going to take what we learned and use it to do these with circles, okay? So the red circle is the whole. What fraction of the whole is missing? So what is missing here? Now you can label, and you have to write the fraction in 2 different ways. So you can look and say, okay, well, I know that that's half. So I'm going to write 1/2. And 1/2 is equal to what? So you have options in order to do this. You can go back to this slide and go 1/2 is equal to 4/8. So I'm going to put 1/2 and 4/8, or you could draw it out. I also provided you guys with these circles, you could actually draw lines within them as well in order to help you out with this. So let's say I wanted it into fourths. This is already split down the middle, and now it is split in fourths, okay? So when you look at it, now how many is shaded, or how many is missing? 2 out of 4. So 1/2 is equal to 2 out of 4. So I hope that that makes sense. And you can do that with the rest of these. And I'm going to show you one other tricky one. So now we're in fourths. How much is missing? And what is that equal to? Oh, and for this one, you could split it into eighths by clicking the line tool. All of these little dots all around can help easily guide you to make those straight lines. Okay, so now I've made that line, and now I've made this line, and now it's cut into how many equal pieces? 1, 2, 3, 4, 5, 6, 7, 8. So how much whatever this is now equal to what? That one I'm not going to give you the answer for. Okay. This is the complicated one because it doesn't go with the lines that are around the circle. So if you wanted to create more lines in order to figure out what the equivalent fraction is, you can't use these things, the dots. You have to kind of make your best judgment of how to split these up. That one I could use the dot. And then otherwise, that would just be how you do it like that. So you can't really use the dots for this one because where the placement of it is different than the others. Okay. And I believe, and then there's one more. And then that you have one question. How do you know when the fractions are equivalent? Multiple possible answers here. and I am out of time, and I will see you for English language arts.